All right, moving on with vectors. Before we have been talking about vectors in terms of magnitude and direction. So, for example, 3 inches at, I don't know, 22 degrees, something of that nature. Okay, we could have another one here, and we say, oh, look, this one is 2 inches at 315 degrees. You'll notice it's always from standard position, which is the positive x-axis, always from 0 degrees around in a counterclockwise fashion. Now, that's all well and good, except that we have an alternative means of talking about vectors, and that is every vector, much like a parametric, has a horizontal bit to it. So as I move down this vector, I'm moving over. As I move down this vector, I'm also moving down, or in this case, over and up. And so we have two components. We have an x component, and we have a y component. Now, this shouldn't be that terribly challenging, but you say, well, how in the world do I find those various components? Well, this happens to be 45 degrees for a reference angle. And so we say, well, let's see here. Cosine of 45 degrees equals adjacent over hypotenuse, so x over 2. So if I multiply both sides by 2, I come up with this. X equals, and that's going to be 1 over root 2. So you end up with root 2. That seems to be the distance for x. Now, if on the other hand you want to do it for y, you would say, hey, sine of 45 degrees equals y over 2. And you would come up with y equals 2 sine 45, y equals root 2 again. Now in this case, since we're moving down, it's going to be negative. We can accomplish that with putting the negative in the negative 45, or we could look at the picture just as we always have done. So our answer here would be, our vector could be 2 comma 315, which of course you could plug 315 in for each of those as well, being coterminal. Or what we could do is we could label them by their x and their y. And so the x component was square root of 2, the y component was negative root 2, and again I'm going to put the arrows on each end to show that this is a vector. So we have a component form here. A component form. You have the x bit and the y bit. Now, additionally, we could even go further, and we could write it in yet another form. We could say root 2 root 2i minus root 2j. Now, I simply indicates that you're moving in the x direction. J indicates you're moving in the y direction. You say, well, why don't we just use x and y? Well, because x and y are always taken already by other variables. Just like in the center of a circle, it's h and k go with x and y. So I and j go with x and y. So this is called unit vector form. This is component form. And this is magnitude direction form. So all of these forms are what we need to put together. Now, let's go over here and do something a bit more difficult. Let's go back to our 3 inch at 22 degrees. In this case, it's not going to be quite as easy because we don't know all these by hand. So let's use the formulas. Now, let's simplify this so that we can simply say, well, what would the x bit be? And that's going to be r cosine theta, where r, of course, is the resultant. Y is equal to r sine theta. And we found it by the same method here. We just save ourselves a step by memorizing the two formulas. So we say x equals 3 cosine 22, y equals 3 sine 22. And we plug those into a calculator to find that x equals 2.78, y equals 1.12, so I can write it in terms of 2.78 comma 1.12, again with the arrows indicating vector, not point. And we could also say 2.78i plus 1.12j. So we have magnitude direction form, we have component form, and we have ij form. We'll talk a little bit more about how to use these two forms in the next section.